Welcome to a lesson with Dr. Powell. Let's take a look at some inverse trigonometric functions and their derivatives with some rationale or intuition for why these formulas might be without any rigorous proof, kind of just in review. So sine inverse, what is its derivative? I'll first write down the formula for its derivative. Let's think about some rationale for this. Let's remember what sine inverse is. It's a function which goes from ratio to angle. So you input a ratio and you output an angle. So let's think of a triangle, for instance. The output is the angle. So this theta might represent the output of sine inverse. And maybe the ratio is x over 1. So x over 1 being sine. But you take x over 1 and you end up getting theta. So it kind of reverses what sine would do. Okay, so now you know what this side is? Using the Pythagorean theorem, this other side is square root of 1 minus x squared, which should make sense because we're thinking of this as being the sine of the angle. And so this would be what? The cosine of the angle down here. And this is simply which cosine is the derivative of sine. So really what we're doing is we're taking 1 over the derivative of sine, or we're taking the reciprocal of the derivative of sine. Should make sense because when we take an inverse function, we swap input and output. We swap x and y. We swap rise over run to run over rise. There is a reciprocal type relationship there. So this should make a lot of sense here when we say 1 over cosine theta. Okay, so we take a derivative of this, we should get this. Now notice also that as x, this side right here, increases, the angle is increasing. Hence, this makes sense that this is positive. Keep in mind that things are restricted here, of course, where x actually goes from -1 all the way up to +1 in here. Okay, so now let's look at cosine inverse. Now, by symmetry and everything else, as this goes along, it actually looks a lot the same, with one difference. It's the negative. So if we think about a triangle here, and we think of, in this case, it'll be like x over 1, so adjacent over hypotenuse. And as x increases, what does theta do? It's actually decreasing, hence we could expect a negative derivative. So these are our two formulas here. Sine and cosine inverse have a very similar form. +1 over square root of 1 minus x squared, and cosine inverse has -1 over square root of quantity 1 minus x squared. Thanks for watching.